Okay guys, this is module 10, practice problem number 3. It says the following reaction is performed in a lab, and we've got a couple compounds mixed together to turn into other compounds. We got sodium sulfate, we got aluminum nitrate, and we've got aluminum sulfate and sodium nitrate, basically swapping out the polyatomic ions. But what I did write in red, because it's going to be important to see this, are the stoichiometric coefficients. 3, 2, there's 1 there because nothing's written, and 6 over there. So the things that we have to think about is the aluminum nitrate, which is this stuff here, and it asks us, the end of our question, it asks us how many grams of aluminum sulfate. So we're looking at aluminum sulfate. Aluminum nitrate and aluminum sulfate. Guess what? The rest of these we can ignore. They don't exist because we don't have to think about them. They do exist, but we don't have to think about them. So we can kind of simplify the problem a little bit. So the bottom line is we're given some information about aluminum nitrate. These two pieces of information, the volume and the molars, for molarity, are going to help us find moles, and that's going to help us eventually get to the question asked for grams of aluminum sulfate. So this is the end of our tunnel right here, the end of our problem is to find that. So to do that we need to take this information and get moles, convert that with that 2-to-1 ratio here to get moles of aluminum sulfate, and then convert that back up to grams, and we have completed our problem. So I'll work that out for us. But before we do that, we need to make sure all our units are compatible. In other words, we've got milliliters here, but the problem is, as we're dealing with milliliters, this molar is the same thing as moles over liters, not milliliters, so we got to convert that milliliters to liters. Okay, so we've turned it to liters, but what we really want to know is moles, because that moles is going to help us to do the stoichiometry to get us to eventually the grams of this other substance. So we do know that molar is the same as moles over liters of solution, moles of solvent, solute over liters of solution. So if I did a little algebra, I could get moles on one side and the rest of these on the other side. Basically, if I multiply both sides by liter, that's going to allow me to cross out the liters on this side, and that's essentially going to give me moles equals liters times molars. Liters times molars. Everything else has been crossed off. So I got that equation I can work with. There, I did a little erasing, but I've got that newly revised formula here. Moles equals liters times molars. I've got liters and I've got molars here. So if I calculate that out, I've got liters being 0.6900 liters times 2.50 molars. Instead of writing molars, I'm going to write what molars are, which is moles over liters. I'm going to put moles divided by 1 liter. And you can see what I'm doing here. Basically, I'm going to take the liters out of the equation and end up with moles for my answer. Liters, 0.6900 times 2.5, and then come up with moles. I'll do that calculation now. Okay, my calculator came up with 1.725. That's 4 significant figures. The least amount of significant figures in our question is 3 here, 2.50. The 0 on the right always is significant if there's a decimal. So I'm going to keep 3 of those significant figures. So 1.725 will be 1.73. And what's our unit? What's left is moles, so I'm going to put moles there. So now we've converted our milliliters into liters. We've used this information to find out how many moles. It's basically 1.73 moles, and we can now work the equation to kind of work our way over to aluminum sulfate from aluminum nitrate. Okay, so with that 1.73 moles, to convert it, this is moles of aluminum nitrate, and O33, that needs to be multiplied by moles of aluminum nitrate at the bottom of an equation and moles of aluminum sulfate on the top. What's the ratio? Well, aluminum nitrate is 2, aluminum sulfate is just 1, so that's the ratio. So essentially we're going to take 1.73 and divide it by 2. We'll also be able to cross out, so you can see how this works cleanly, moles of aluminum nitrate crosses out with moles of aluminum nitrate, and we end up with moles of aluminum sulfate. So if I just take that 1.73 and divide it by 2, I should have an answer. There's 1 times 2, and my answer came up to be 0.865, and we can keep that, moles of aluminum sulfate. Excuse my handwriting. Can we keep all those digits? Well, we had 3 significant figures here. We have 3 significant figures here. That 0 doesn't count because it's on the left. Those never count. So that's how many moles of aluminum sulfate we have. Now we can write that up there. So just to recap, we've changed milliliters to liters. We've converted all this information to moles of aluminum sulfate. And if you can see, if it's a 2-to-1 ratio of aluminum sulfate and aluminum nitrate, we're just going to have half of that in moles for aluminum sulfate, which I showed you the long way of figuring that out. And now we just got to convert that moles of aluminum sulfate to grams of aluminum sulfate. We're done. So now I'm kind of reminding you how to get to grams from moles. We've got 0.865 moles of aluminum sulfate. And what that means, we've got to find out what 1 mole of aluminum sulfate is in grams. And so essentially I got 2 times 27.0, that's what aluminum weighs. And that's because we have 2 aluminums. And we got 3 times 32.1, that's because we've got 3 sulfates. Each sulfate has 1 sulfur atom, but we've got 3 of them because we got that 3 next to the parentheses. So 3 times 32.1 for sulfur. And then oxygen, we got a lot of oxygen. We've got 3 times 4 oxygen, because each sulfate has 4 oxygen. We got 3 of those sulfates. So it's going to be 12 times 16. And I'll clean that up and show you how that works. Oxygen, that'll all add it up to 342.3 grams. And as you can see, since we're multiplying those together, we can cross out the moles and end up with grams as our unit, which is exactly what we want to do. So we just have to multiply this top row. Both numbers on the bottom are 1, so that shouldn't be a problem. I'll do that now. Okay, I multiplied those two together, crossed out the moles, ended up with 296 point bunch of other numbers. These are 3 significant figures because these are 3 significant figures here, most limiting. So I basically took 0.865, multiplied it by 342.3, kept the grams, crossed out the moles, and we've got 296 grams. So 296 grams of aluminum sulfate is our answer. Make a nice big square so your teacher can find it, or your TA. And that's practice problem number 3 for Module 10.